So what we're going to cover in today's lesson is building on our writing linear equations, but we're going to use that in the context of actual scenarios as opposed to just abstract numbers. But we also want to introduce a new concept today called direct variation. And in math, a direct variation is a relationship between two variable quantities whose ratio is a constant or is constant. When graphed, it will go through the origin, meaning its y-intercept is 0. That constant is called the constant of variation, that constant ratio. All right, so let's take a look at this in the context of a couple of problems. All right, first is the amount of money David could raise for a charity bike-a-thon. Now, is this a direct variation? Well, the way you would look at it is every time I can, if I can multiply my independent variable, biking time, by a constant value and always get my dependent variable, then it is a direct variation, because the ratio of each of these, 20 to 10, 40 to 4, or 20 to 2, 60 to 6, are a constant. So is it a direct variation? Yes. The ratios all result in the same constant value. Now, looking at this in a graphing context, and one of the things I want to just point out to you is when you graph in math, okay, you don't want to confine yourself to just 1, 2, 3, 4, 5, or whatever. So the equation for this, y equals 10x. So my independent variable is time, and dependent is dollars, okay? And what I can do is the time goes from 2 to 6. So I'm going to count 1, 2, 3, 4, 5, 6 to spread this out a little bit. And my money goes from 20 to 60. So here I want to count. I can't count by ones. I won't fit. Can't count by twos. Not even 5. So I'm going to count by tens. So 10, 20, 30, 40, 50, and 60. Now, what's my first coordinate? Well, it's the coordinate 0, 0. Because if he bikes 0 hours, he's not going to raise any money. Then I go to 220, 4, 40, 6, 60. Now, what's important here is I put an arrow at the end because he can bike more than 6 hours, but I don't put an arrow at the beginning at 0, 0 because I can't bike a negative number of hours. All right, let's continue on. Slope is also known as the rate of change. It is the amount that is applied to the independent variable, which is x. The y-intercept is considered the fixed amount because it does not change. Y is the dependent variable because its value depends or relies on the independent variable. Okay? So, it costs $3.50 to develop a roll of film and $10 for each picture developed. I want to write an equation for that. Well, y equals 0.10x plus 350. My slope is the 0.10. My y-intercept is the 350. Now, more importantly, what does the slope represent? It's the cost per picture. If you can write the word per in there, or each, that's the clue that that's the slope, because that's the rate of change. What does the y-intercept represent? The fixed cost to develop a roll. Now, what would it cost me if I wanted to develop 30 pictures? Well, the easiest thing to do is put in 30 for X, and you'll get $6.50. Okay? Is the above relationship a direct variation? No. There is no constant of variation. Now, what does that mean? Well, in other words, if I just developed a little table here of 3 values, okay, when I divide y divided by x, here it's undefined, so I'm not even going to put anything. Here it's 360. Here it's 135. So I can't multiply x by a fixed amount and get my y, okay? So that's why it's not a direct variation. All right, here is table for cell phone plan. All right, so what's my equation for this? Well, as you can see, the minutes go up by 100. The cost goes up by $10. So that's 10 over 100. Since we're dealing with money, we want to write it in decimal form. So y equals 0.10x. Now, y-intercept. Well, the y-intercept is when I use this for 0 minutes. At 0 minutes, this is going to cost me $8. I just work my way back. Okay? So the slope, 0.10, y-intercept is $8. So what does the slope represent in this problem? The slope represents the cost per minute. What does the y-intercept represent? The fixed cost of the plan. Okay, in other words, if in a particular month I didn't use my phone at all, they still would send me a bill for $8. Okay, that's what we're talking about. If I use 750 minutes, what's going to cost me? Simplest thing, plug this into your equation to get $83 for that month. Is it a direct variation? No. There is no constant of variation. A little messy here. No constant of variation. So in other words, this is no, okay? If you go back above to the table, I can't get my cost by multiplying the minutes by a fixed number, all right? These are all different amounts. All right, let's go to the last example. Now, I have to draw even though you'll have it on your piece of paper, but I need it up here. So I have a scenario where here's my time, okay? So 1, 2, 3, 4, 5, 6. My distance. So that's distance. So I want to come up with an equation for this. The two things I need are my slope and my y-intercept. Well, let's do the easy one. The y-intercept is 300. Let me graph the line. Let me get that going a little straighter here. My y-intercept is 300 because that's where it intersects the y-axis. My slope, well, here's the coordinate 0, 300. Here's the coordinate 5, 0. I use my formula, 300 minus 0 over 0 minus 5, and I get negative 60. So what's the equation that I can write? y equals negative 60x plus 300. Now, the negative 60 should be making some sense to you because as time goes on, okay, as time goes on, as time increases, the amount or distance decreases. So what's a scenario that can replicate that? Well, suppose we're talking about somebody is hiking and they're at 300 feet high. What is their height as they keep hiking down? Okay. So that's why. And then if you look, the line is going up to the left, which is a negative slope. Is this a direct variation? No. There is no constant of variation. In other words, if I made a little table of values for this, so at 0 hours, I'm at 300 feet, okay? And then after 1 hour, I'm at 240. 2 hours, I'm at 180. 3, 4, and 5, I'm at 120, 60, and 0. If I did y divided by x, this doesn't work. That's 240. That's 90. That's 40. That's 15. And that's 0. This is not a constant. That last column is not a constant. Okay? So that's the reason why that last one example is not a direct variation.